the one molecule that I'm the most excited about of having direct effects both on muscle growth and marbling is biotin. And knowing that biotin affects enzymes similarly to, say, a beta-agonist, I think there's opportunities to enhance muscle growth.
Welcome to the Rumination Podcast presented by Jefo Nutrition. I'm your host, Dr. Greg Eckerley. Today I'm pleased to have with me Dr. Brad Johnson to discuss metabolism in cattle for muscle development and overall development. Dr. Johnson currently sits as the Gordon W. Davis Regents Chair in Meat Science and Muscle Biology and a professor in the College of Agricultural Sciences and Natural Resources at Texas Tech University. Prior to his appointment at Texas Tech, he was an associate professor at the Department of Animal Sciences at Kansas State University and worked in the Extension Ruminant Nutrition Office with beef and feedlot specialists, and as well worked at South Dakota State in the Department of Animal and Range Sciences as an assistant professor. Dr. Johnson is a native of Millbank, South Dakota, and he earned his bachelor's degree from South Dakota State University and a master's and PhD in animal science at the University of Minnesota. Football season is upon us, so are we rooting Red Raiders or Golden Gophers?
I'm going to go with the Red Raiders this year, Greg. So
there you go.
You know, we have a big game, though. K-State comes to town, so that K-State, Texas Tech should be a great football game. So
that should be this year. Should be. So welcome to the show.
Thanks for having me, Greg. I'm honored to be a part of this podcast, and hopefully we can offer some information that's valuable to your consumers and producers. So
I hope so, and I hope I don't lose them today with a slightly more technical talk, but, you know, sometimes I have to let my inner PhD shine too. So we'll go ahead and get started with that. And so looking at muscle development, what roles do we see that coenzymes are playing in upregulating energy to help with growth?
So, Greg, I think to maybe get at that question, I want to back up a little bit and make sure the audience understands some of the basics of postnatal muscle growth. So, in all of our meat animal species, anything we may deal with from a livestock or animal and even an avian or poultry nutrition standpoint, when we deal with skeletal muscle, the number of muscle cells or muscle fibers is fixed at birth. And that becomes very critical from a growth standpoint. So all the growth that we have postnatally is what we call postnatal muscle hypertrophy. So we got to make those individual muscle fibers bigger. We're not going to ever get any more muscle fibers. And so the main way we do that is by increasing protein synthesis. So we want to, if we're going to see an increase in muscle growth or muscle hypertrophy, we're going to have to increase the rate of protein synthesis. And skeletal muscle is very dynamic in that we're going to break down almost as much muscle as we make every day. So we're always continually increasing protein synthesis to have an increase in muscle growth. And the proteins that we're dealing with in skeletal muscle are some of the largest proteins in our body. So, for example, the most abundant protein in skeletal muscle is myosin, and there's different isoforms of that. We'll talk about that in a later question. But myosin is roughly 520,000 Daltons, okay? So it's about 4,000 amino acids would make up one myosin molecule, which is a hexameric enzyme. So there's 6 different subunits. We would estimate it takes 5 ATPs for every peptide bond. So if we're making one molecule of myosin, we're going to basically need 20,000 ATPs to do that. The largest protein in skeletal muscle is a single polypeptide chain called titin. Titin will span half a sarcomere. One molecule of titin will span half of a sarcomere, and that is 5 times bigger than myosin. So in the case to make one titin molecule, we're dealing with almost 100,000 ATP units. So obviously protein synthesis is going to take a lot of energy. Now, we're competing with that, right? Every time we make these new proteins, the functionality of myosin and actin is basically for muscle contraction. So every millisecond or whenever we have a linkage of the myosin to the actin, we need another ATP. So it's not surprising that energy needs for both postnatal muscle growth as well as the functionality of skeletal muscle, that being contraction, we need a lot of ATP. And of course, we know that the coenzymes are going to assist with this, right? All the way from the shortest burst of energy that we're going to get to produce ATP in muscle is the ATP-PC system, which is the phosphocreatine system, which within seconds can produce ATP. We have enzymes involved there that also include coenzymes. We then have glycolysis and the Krebs cycle that are producing a lot of ATP as well as reducing equivalents, which ultimately find their way into the electron transport chain. So all the way from thiamine to niacin to riboflavin, pyridoxine, biotin, cyanocobalamin, pyridoxine, pantothenic acid, all these are all coenzymes, very important from an energy metabolism for every cell, but it becomes very critical for postnatal muscle growth because protein synthesis is so demanding that we have ATP.
Perfect. Yeah, it's amazing. You were doing that, and in my mind, I was sitting there calculating the ATP generation for myosin. I was like, man, that's a lot of glucose that has to get shunted down glycolysis to get through the Krebs to generate that much ATP. So that's a lot of calories, folks. A lot of calories. And so when we take that into account and looking at some of the developments that you've been working on, but looking at some of the nutritional science and the foundational with our current genetic improvements and developments that we've made in the beef industry from when this research was initiated back in the 40s, 50s, 60s to today, can we hypothesize and think that genetic development and advancement has placed a higher demand for certain nutrients that were historically not apt to look at?
Right. And that's a great question, Greg. And I think back 30 years ago, or a little bit more than 30 years ago, I started my research career, and I started working with a synthetic androgen that we still use today in implant formulations for beef cattle in the United States and Canada as well, around the world, trenbolone acetate. And our thought early on was, well, if we have aggressively implanted cattle, then they must have higher nutrient needs, right? Certain nutrients like crude protein or specific amino acids or even calories. Do they need more energy? And in reality, those growth enhancing tools did not change the needs for some of these. They made them more efficient, right? And so today, our cattle genetically and the way we feed them, nutritional management, we have some of the best feed conversions we've ever had in our beef cattle industry worldwide because of our advancements in genetics, feeding strategies, total nutrient requirements. So somebody might say, well, then they should require less of some of these nutrients. But the interesting thing, what we just got done talking about of these coenzymes affecting energy metabolism, I would argue that in fact, at a tissue-specific level like skeletal muscle, in fact, these high-performing animals, beef cattle that are genetically selected to be extremely highly efficient from a feed efficiency standpoint, we have to make sure that we have all the nutrients present for that efficiency to happen. And what the caveat of all this, what we have seen is that, and I think we first started seeing this in non-ruminant species maybe 20 years ago, like poultry and swine, is that when everything is going good, these animals are extremely efficient, right? They're really good at taking feed nutrients and developing edible tissues like skeletal muscle or adipose tissue. But if we have a hiccup and we have a health challenge, these animals are prone to really go downhill a lot. That health challenge becomes much more detrimental in our very efficient, fast-growing animals today compared to maybe beef cattle 30 or 40 years ago. And I think we saw that evolution in the non-ruminant side first, right? If we have a disease challenge in these animals, they got to pull the nutrients from something. And they're so programmed now for fast, efficient growth that sometimes their immune system cannot keep up under a disease challenge. And we've actually seen an increase in death loss in cattle over time because I think it's hard to partition this energy different ways very quickly. And so when the cattle are healthy, I think we got some of the most efficient, fast-growing cattle today under the same general plane of nutrition that we did 30 or 40 years ago. But the caveat is when we have challenges, these animals are more prone to morbidity and mortality than they were 30 or 40 years ago.
I would definitely agree with that. And we were talking about a disease challenge, but if we look at, and I'm going to use this summer in particular, over here in Dallas, we were very mild all the way up through June, and then as soon as July 1 calendar said, for some reason, it's like, okay, the preheat's over. Here's 90 days of 100-degree plus with nighttime temperatures of 85. Probably similar to what was happening over in the Panhandle and other cattle feeding areas. So can we transition that disease stress over to just a heat event stress or prolonged thermoneutral challenges?
Right. No, I think you're exactly right. I think what happened, especially during heat stress, and I think cold stress is equally as damning to animals, but we know that during heat stress, the the absolute mass of feed intake is going to go down, right, during heat stress. So it's even more critical then to make sure that some of these micronutrients, like the coenzymes and the B vitamins we've been talking about, are actually at a higher level in the diet probably, so they're meeting some absolute requirement in the diet. But we also know, heat stress can be so damning to hind gut health, for example, in all species, but we're learning so much in both beef and dairy cattle. And there's another role, for example, like choline, or some of these betaine and choline are being methyl donors, have been shown to be very positive from helping reduce, say, leaky gut during heat stress. But I think all the coenzymes, the whole metabolism factor becomes very critical during those periods of stress.
Perfect. And then as we talk about those critical times and thinking about muscle and fat development for finishing cattle to get quality grades and then also maintain that proper fat to meat ratio, where do we see that in that animal's life being one of the more critical time points and periods for proper finishing?
Sure. So, the muscle deal is interesting because again, back kind of what I just talked about, it in a real healthy, rapidly growing animal that has high levels of dry matter intake, the natural processes of muscle growth right after puberty, for example, that's a period of time where we have the steepest period of muscle growth. And so one might think, well, is there opportunities to even push that farther? And I think there probably is by fine-tuning some of the nutrients that we've been talking about. But really where we probably have the biggest opportunity, Greg, to improve muscle growth is when skeletal muscle is going to see that natural plateau effect. And that all goes back to what I said earlier. We have a fixed number of muscle cells, and we're relying on hypertrophy to make it bigger, but we also have these special cells called satellite cells that can start proliferating and support that postnatal muscle hypertrophy. As an animal gets near harvest time, finishing time, later in the finishing period, we see that plateau effect of muscle. That's where I think there's a lot of opportunities to extend that growth curve of muscle. We've seen just in changes in genetics the last 10 to 15 years, it's been amazing how cattle used to kind of hit a wall, right? Their dry matter intake would drop. We knew they weren't gaining very much. Today, those cattle, they may weigh 1,500 pounds and still be gaining 2.5 pounds a day. But yet we do know that protein deposition is starting to plateau. I think that's the most critical period, and that's probably offers the most opportunity for interventions with products like Jefo would have, different coenzymes, to try to basically alter that. That's one thing with the exogenous growth promotants like steroidal implants. We know that the steroidal implants are going to be very critical at pushing that skeletal muscle growth curve at a heavier weight, and that becomes really important from a feed efficiency standpoint. In regards to the adipose tissue or the finish, as we get close, looking at lipid deposition or adipose tissue, obviously marbling development has become very critical, right, from an economic standpoint. USDA prime carcasses today are worth more than ever before, and the premium between prime and choice has been very strong for the last several years. That marbling, even though we talk about marbling being the last lipid to be deposited, which it is, the cells that ultimately are going to fill with lipid, it's a lifelong event. In fact, we can find marbling adipocytes in a developing bovine fetus. So it's a lifelong event. And so basically there's opportunities to try to get more of these cells throughout the entire growth period and then allow the lipid filling at the end. So back fat, which we also often, don't want a lot of back fat because it affects feed efficiency, we usually have no problem. That's almost exponential growth at the end, right? But we're always challenged both with muscle growth and marbling filling or adipocyte filling at the end. And I think that's the greatest opportunity. If we could extend the growth curves of both muscle and marbling at the end, we would have great opportunities from an economic standpoint, but also an efficiency standpoint.
Yeah, because it's amazing that new end target and these animals are still pushing. Yeah, they're not as efficient as they were at 1350, but it's just, hey, we're still seeing an economic impact for us to keep on longer days on feed just because they're not turning off. And so I think that's interesting what we've been able to do genetically there. And so looking at that, can we utilize certain vitamins like biotin or certain things like that in certain feeding period roles to maximize this potential or things like that to alter or program metabolism for these animals as they go through the feeding period?
Sure. And I tell you what, biotin, it's so intriguing to me. So first off, I think there's a lot of anecdotal work out there, and I think it started in Australia, but a lot of people on the Wagyu cattle, the heavy marbled side, felt they could increase marbling by feeding elevated biotin to ruminants. And first off, if we feed a high grain diet to finishing cattle, the one B vitamin that's probably going to be compromised the most in the rumen is actually biotin, right? So there's reason to believe we should be thinking about maybe providing a protected source of biotin. But the interesting thing with biotin, it's a component of several coenzymes, right? Or it's a coenzyme for several enzymes, I should say. Two of the big ones from a de novo lipogenesis or fatty acid synthesis standpoint, acetyl-CoA carboxylase 1 and 2. So naturally, people thought, well, biotin's going to stimulate ACC activity. We should get more lipid filling, more triglyceride synthesis. And the data is not, there's anecdotal reasons to believe that works. But I think subsequent to that early work on marbling development, we've learned a lot more about biotin. And the thing that excites me the most about biotin is that it activates a very important enzyme that I've studied a lot from a growth promotion standpoint. And that enzyme is AMPK, the AMP-dependent kinase. So AMPK, not to be confused with cyclic AMP-dependent protein kinase, AMPK is basically in every cell. And it's a thermostat or an energy sensor. When AMP levels are high, the implication is we don't have a lot of ATP left because we've metabolized all that. It activates this enzyme, which basically shuts off certain pathways, including acetyl-CoA carboxylase is a major target. AMPK activation actually reduces ACC activity. But we've worked with AMPK with growth promoting, specifically beta-adrenergic agonists. When we feed beta-agonists like ractopamine or zilpaterol to cattle, we'll see an increase in AMPK and an increase in the abundance of phosphorylated AMPK, which is the active form. Biotin does the exact same thing, which is somewhat counterintuitive because you're thinking, wait, this is going to shut off certain enzymes that are important. But we have to remember what marbling needs. Marbling is just like muscle. Marbling needs glucose as an energy substrate to develop lipid filling, right? Triglyceride synthesis. And the one thing biotin does by activating AMPK, we actually improve glucose uptake. We've shown a change in GLUT4, In fact, biotin will stimulate glucose stimulated insulin secretion from the pancreas. So biotin is so much more than just a component or a coenzyme for enzymes like ACC, right? And I think this offers the most opportunities. If we start losing some of these exogenous growth promotants like beta-adrenergic agonists, we know the mechanism now of how some of these exogenous compounds affect growth. I think biotin is a natural alternative that can do the same thing. And there's some work done with biotin in conjunction with like chromium and betaine, where in fact they did see positive results on marbling and muscle growth. And I think when you understand the biology of what each one of those are doing from a glucose metabolism standpoint, it makes perfect sense that biotin is affecting AMPK, which ultimately is causing changes in muscle fiber type and muscle growth as well as marbling development. So I think there's a lot of opportunity going ahead on the feedlot cattle side with biotin.
The real question is how do you get it past the rumen, right?
Yeah.
And maintaining
I'll leave that up to you, Greg. So.
Right. No, yeah, most definitely. And it's just one of those, when you think about it in that class of vitamins, you're like, okay, rumen microbes get first crack at everything. I mean, that's just what we're always taught as cattle nutritionists, is you're feeding the bugs first, and then the animal gets the byproduct of what they're doing. So that's something that we have to be cognizant of. And that's interesting though, man, taking me back to metabolic pathways. I love it. And then, so when we think about that, and then looking at on the flip side of things, we're talking about potentially losing things and regulatory changes. One of the big ones that took place July 1 was regulatory changes in implantation. And then following that up with GFI 263 with the over-the-counter antibiotic changes going to prescription. How do we feel that we could use nutraceuticals or more natural products to fill that gap that we may be having? I mean,
right.
And particularly with the implants.
These things all probably started with the 213 document, the VFD, almost 10 years ago, right? The veterinary feed directive, where basically we'd lost the ability of in-feed antibiotics to be used as growth promotants, namely tylosin and chlorotetracycline. So it really started there. The GFI 191, which is the Guidance for Industry 191, that changed kind of the classes of cattle and how we can re-implant cattle, that was going on at the same time as the over-the-counter antibiotic. And I think this, to be honest with you, Greg, this is just the beginning of more federal regulatory oversight of these kind of medicated feed additives and products that have to be approved by FDA. Obviously, the implant changes may be a short-term issue right now, because pharmaceutical companies will have the opportunity to relabel their products. And so we already have some products that we recognize the name of that are approved for reimplantation in a single phase, namely the finishing or confinement phase of growing and finishing cattle. The antibiotic deal is probably going to be more widespread. I've heard that the next thing that the agency wants to attack is, instead of continuous feeding of antimicrobials like tylosin to prevent liver abscess, maybe now we'll just be able to feed it a given period of time, phase feeding. And I think that opens the door for natural products or nutraceuticals, phytogenic, whatever you want to call it, but definitely things like coenzymes would fit into that category, where I think understanding how the mode of action of these will become very important. For example, the liver abscess issue has actually gotten worse in many of our cattle, especially our beef on dairy cross cattle. The incidence of liver abscesses could be high as 70 or 80%. And obviously, maybe we could learn something with coenzymes and other nutraceuticals to try to replace, traditional antimicrobial use to try to prevent that. So I do think we're going to see continued pressure on medicated feed additives, antibiotics, and even growth promotants like implants and beta-agonists becoming more regulated. But I think that opens a door for more opportunity with some of these more natural alternative products.
No, I would agree with that. And every regulation seems to get more stipulated and harder to find. And granted, in everything, and I've read both of them, there's gray area in both. So it leaves interpretation up, but then is it interpretation that you're going to end up with a fine? What is the fine? Things like that I'm like, what's the government going to do next to really put a challenge on our food production systems here in the United States? And so I just sit there and I agree with you 100% that I'm like, okay, what we are going to have to look for new solutions that are outside government purview. Don't mean to get off in the weeds there, but I was just like, things are looking different for our model here in the United States in the next few years.
Well,
So
and I
with
think,
that,
and I think that's okay. That's a good thing, right? I've worked with anabolic steroid implants for over 30 years. And I tell people that I've learned a lot about the mode of action of these, right? And the whole goal is, if we can figure out the mode of action, if there's natural ways to do it, I think it behooves us to look at those opportunities.
I would agree. And isn't it a Bob Dylan song about times they keep changing? Am I right on that?
Yeah.
So they do. So in conclusion, would you mind sharing 3 of your main take-home messages that we talked about today with the audience?
Sure. Well, I think first off, I think we often forget the energetic cost, and not really cost, but protein synthesis is not a spontaneous event, right? And we think of muscle as the main protein reservoir in the carcass, obviously, and that comes at a cost. It takes a lot of ATPs. When you start thinking about these large proteins that we're turning over all the time in muscle and have to replace, it takes a lot of ATP to do that. And all these items that we've talked about from a B vitamin and coenzyme standpoint assist in that ATP production, all the way from the ATP phosphocreatine system in muscle all the way through the final stages of electron chain, the ETC, the electron transport chain. So that's a big thing to think about, is where's that energy? That's why we need to be above maintenance, right? To have muscle growth, is we got to get the ATP. The other issue the other big take home that I think, the one molecule that I'm the most excited about of having direct effects both on muscle growth and marbling is biotin. And knowing that biotin affects enzymes similarly to, say, a beta-agonist, I think there's opportunities to enhance muscle growth, but it also then is going to dictate more glucose potentially going into marbling adipocytes. So we should be able to enhance marbling at the same time. And when you get a dual effect like that, I think that's really exciting. And then the final take home is our U.S. Food and Drug Administration, I think, is going to continue to offer regulatory oversight, or however you want to describe it, on some of these medicated feed additives, over-the-counter antibiotics, normal growth promoting techniques like implants and beta-agonists that we've become used to using. And obviously, the more natural alternatives that we can seek and find and utilize in our industry, I think the better off we're going to be in the long run.
Perfect. Well, thank you for being here today. And it was wonderful chatting with you on this. And I really appreciate your insight, just because it put me on a higher level thinking order where I was like, wow, I didn't think about it that way before. And now it's like light bulbs going off in my head. And so I hope they can go off in the head for our audience. And so really, again, appreciate you being here. And hopefully this school year, 2023-2024, Tech does well football wise. And then your school schedule and your students trump off and make you proud as well.
All right. Well, I really appreciate you guys inviting me, and hopefully, again, some of your audience and producers will find this interesting and helpful as well. So thank you, Greg.
Sure, appreciate that as well. And I surely want to thank our audience for listening to us today. I'll remind you that you can subscribe to our channel at jefo.ca. And so you won't miss our next episode of Jefo Rumination Podcast. Please find us at jefo.ca, Apple Podcast, Google Podcast, and Spotify. This podcast was brought to you by Jefo, Precision Nutrition for a Growing World.